Okay, so let's move into the worksheet number 7 from the lecture number 7. So lecture number 7, we mainly talk about the conservation of momentum and the impulse. Those are the things that we discuss, right? So it's very important. Other conservation, we discuss about the energy conservation in lecture number 6. And here we are talking about the momentum conservation. So momentum, we define it as a lowercase p, and that will be property of moving matter, that we can write it as mass of the object times the velocity. This is a vector always, right? So since it is a vector, we need to be very careful with the your uh, calculation, because we need to consider the directions also. Now, as soon as you see it is mass time velocity, the units will be kilograms is mass and velocity is meters over second, and this will be the units of the momentum. So that units also will be equal to the impulse of the impulse units. So impulse will be basically, we can write force and time. Because of that, this will be also equal to newtons and seconds. Okay. These both are the same units for the momentum. So now momentum, we can write it for the individual objects, you can write it for the systems of object, right? But important thing is this quantity also a conserved quantity. That means you can conserved quantity. So that means you will be able to write initial momentum is equal to final momentum. It's very important. This information should have a direction, not like energy. So that is, we call it as momentum conservation, right? So, but there is very specific constraint in here that we need to consider. Net external force acting on the system at that time should be equal to 0. That is the momentum conservation. Simple example, if I have one ball moving with initial velocity, we'll say m1, we'll say v1 initial, and if there is another ball mass m2 and moving in backward direction v2 initial, they're going to be collide each other, right? Then we'll say they both are moving on the right direction. According to the information about the masses, initial velocity, they will select different directions of the motion after they collide each other. This is one final, and this is V2 final, right? So what that means, this external force, that means after these objects are moving with these velocities, you should not apply any external force to this system. If you do that, this conservation is not going to work. Because of that, we should have that constraint as always for the momentum conservation law, right? So now if I write it in this example, you know that you need to definitely label your coordinates, because we are working with your vectors in here. So anything to the right will be positive, anything to the left will be negative. There is no vertical motion for these balls. We working with the horizontal direction, but you can do it for the vertical direction. Some balls maybe go in different direction. In that case, we need to use the horizontal and vertical both together. But this example, everything is vertical direction. So this is my M1, this is my M2, right? So now momentum conservation is saying that you're going to write your initial momentum of the system towards X direction. That will be equal to, you can get rid of the vector notation in there, because since I have the direction outside, we don't want this bar line in here. We know it is to the right. So now I have M1, V1 initial, but my M2 is opposite direction. Because of that, M2 and V2 initial is negative. And you do exactly same thing for the final. Now both are positive direction because of that M1 V1 final plus M2 V2 final. So now momentum conservation saying that P initial of the system equal P final of the system in the same direction. Because of that, M1 V1 initial minus M2 V2 initial is equal M1 V1 final plus M2 V2 final. So I write this formula only for the question, the problem that I have. It is not a fundamental formula. Fundamental formulas will be this and this. Those are the formulas that you have. Other things you're going to derive to the problem. You cannot have those anywhere. So those are depend on the question. Those we call it as derived formulas. Okay. Okay, that will be the momentum information. So we're going to do it some problems on that section. And in addition to that, we discuss about the impulse. So impulse is something that we need to talk force and time together. Force and times together, we call it as the impulse. What that means is this is again your Newton's second law in different the next format, but what impulse showing you as a simple example, if you hold the tennis racket, when the ball hit the racket, you know that it will create the impulse on the racket and also on the ball. Those are equal and opposite. That's Newton's third law. Pulse will be the same for both of them. They will create the same force. Then they have the same impulse. So impulse usually we calculate only for a single object. So I'm going to write this impulse F times t. We can write it as change of momentum also. Change of momentum. Change of momentum means P final minus P initial. It's very important. The impulse is calculating only for a single object. You are not calculating it for the system, both objects together, only for a single object. Not both objects. When two objects are collide each other, you are doing only for one object. That will be the same for the other object too. As we call as impulse, right? And later on this lecture, we also discuss about the center of mass position, because we know that we use the center of mass position throughout the semester, but we do not know how to calculate it, and we take the center of mass as the object center so far. That is correct if your object is uniform, and if it is a regular object, then we can say it is the center of the object is the center of mass of that object, right? And also that will be the force of gravity acting point. So that's correct. But your objects are not like uniform. Object can be regular shapes. In that case, how do you find the center of mass? If you have two objects, we can do it like simple example. If I have one object in here and one object in here, right, then it is depend on the masses of these two objects. If this one is mass m, this one is mass m, so we know that center of mass of this system is changing. If my uppercase m is greater, then center of mass will be closer to that. If my lowercase m greater, then the center of mass going to be closer to the lowercase m. Depend on which side is heavier, then your center of mass is moving accordingly, right? So now how to calculate the center of mass is, as a simple example, if you use your x direction in here, y direction in here, then you're going to say, okay, I don't know where the center of mass is. We're going to say this is x center of mass. That distance is from your origin to your center of mass. Then you will be able to write x center of mass is equal your m1 object times the distance to m1 from the origin plus m2 object times distance to second object from the origin, and divide it by, let's take lowercase m and uppercase m, as since I have that notation in there, m, and divide by m plus n, net mass, right? If you have 3 masses, you do it 3 of them, right? So that center of mass x can be positive or negative depend on your x1 and x2. It's very important that you choose the origin and write this formula, because sometimes depend on your origin, your x1 and x2 can be negative or positive, right? So we need to be careful with that, but this will give you the center of mass in x-axis. If you have objects in y-axis or in between x and y, definitely we need to find the y center of mass, and then we need to use the Pythagorean theorem to find the resultant distance to the center of mass from the origin. So that's the center of mass part. Yeah, I know that I took a lot of time in here, but we're going to work on the problems to get understanding how we're going to apply those things onto the problems. Okay, so now, okay, so my one pin. Okay, let's see. I put it into the charges. Okay, so now let's move into the question number 1. So question number 1 is about the momentum conservation, right? So it's a simple question, but important thing is the step wise, you need to understand the questions very carefully. That means you should be able to use that information to your new question. Okay, so now let's draw the cartoon first. The train car on the left with the mass m1 is moving with the speed v1 initial. When it collide with the stationary car with mass m2, these two stick together. This, you need to read these words to understand what question is saying, because it can be giving you a different informations than you can see in here. To stick together and move with velocity v. So now we need to draw. We have first car, right? That is mass m1, and there is second car, that is mass m2, right? And then first one is moving v1 initial is a positive number. That means it is going to write the, let's write the first as variable, then we're going to plug the values when we need it. So v1 initial to the right? And then second one is stationary. That means this one does not have the velocity. So we can write v2 initially 0, no velocity. So now we know that first one going to hit the second one, right? So this is the collision. Now it says they stick together and moving with velocity v, right? So that information is important. Now these two going to stick together and moving with the same velocity. Now this both has the velocity v and m1 and m2. Okay, so now this is before collision. This is after collision, or initial and final. So now we need to write, let's move with the question, and question A is asking, write the initial momentum of the system by using symbols given. So now next step is you need to make sure you label your x and y direction, because we are working with vectors now. This is the coordinate system. Right, so I need to write the initial momentum of the system. You see that we need to read of the system by using given symbols. Of the system, we're going to write it in x direction. P initial is equal, you have m1 and v1 initial. So second object velocity is 0, then you don't want that part, right? And then B part is saying, write the final momentum of the system, again for the system by using symbols on. So we're going to use same direction. P final is equal m1 plus m2, both moving with the same velocity. Okay, so now we done the B, and now C. Use the momentum conservation to solve for unknown v by using symbols. So you're going to write the momentum conservation in x direction, P initial equal P final, right? So now we can write it as m1 V1 initial is equal to M1 plus M2 times V, and algebraically your V will be M1 V1 initial divided by M1 plus M2. Okay. So now part D is asking, calculate V if M1 equal M2. Right, so now calculate means I need to calculate it. I'm going to write the formula one more time. Since M1 and M2 are the same, we can write it as M plus M, right? That is 2M. So that means V1 initial divided by 2 will be your final answer. So now it's time to calculate. So V initial is 24. So 24.0 divided by 2. So that means V will be to the right direction, which will be 12.0 meters per second. Velocity is in positive x direction. Okay, so now we're going to move into the part E. Part E asking, show that the collision is inelastic. So we discussed about the elastic and inelastic collision on your lecture part. Inelastic means basically kinetic energy is not conserved. That is called it as inelastic collision. Elastic collision means kinetic energy is conserved, right? That means if you want to show the collision is inelastic, that means you need to show that kinetic energy is not equal, kinetic energy is not conserved. That means initial kinetic energy is not same as final kinetic energy. So we need to calculate the kinetic energy initial first, right? So kinetic energy initial will be equal half M1 and V1 initial squared. Second object has 0, right? So now if you plug the values for the M does not given, but we can use as M, and velocity initial is 24 power 2, and you can write it as, just leave it like this. We just need to compare it. Let's leave it that we don't want more calculation. You can calculate if you want. And then kinetic energy final, we're going to write equal. So you have half. Now your M1 and M2 both are moving with the same velocity, V squared. So that will be M1 and M2 are equal. Because of that, we have 2M over 2V squared. That will be M times V is now 12 squared. So now you see that your kinetic energy initial and final are not equal to each other. They are not the same, right? They are not the same. Because of that, you can calculate kinetic energy initial is not equal to kinetic energy final. That means your change of kinetic energy is not 0. Change of kinetic energy is not 0. That means it is inelastic. You need to show that process. You cannot say it is elastic or inelastic without doing this calculation. So don't use anything other than what we talk in the class. I have seen students doing something not I teach in the class, like calculating E, that we call it as the, we can do that way, but I did not talk that in your class. Okay, so because of that, this is the process that I want you to do to find the collision is inelastic or elastic, not the ones that you see it on the internet or YouTube. Okay, so now let's move into second question. So now this second question is a standard question, although I'm asking in a different way. You may see this question in different places on different format, right? Okay, so now this is the ballistic pendulum. which is a device that you can project the, you see that here, you can project the bullet and there is a hole in this M, and then bullet will go to this object, and then both going to move, do the oscillation up and down, right? So that's, we call it as ballistic pendulum. So now important thing in here is it's not erasing. Important thing here is we're going to use actually combination of conservation of momentum and also conservation of energy. You will see why we need both of them. Okay, so let's read the question. So we need to measure the speed of the projectile. That means the purpose of calculating V in this question. Bullet with the mass M reach with the velocity V and hit the mass M pendulum. You can see this is the bullet here, right? That's the bullet. And then you have the pendulum, that is the uppercase M. Both move together with the velocity V prime. V prime is here after it hit and insert inside. M plus M both are moving with V prime. And reach the maximum height. After that, it's going to reach the maximum height, as you can see, as H. Okay. So now let's move into the question. Now part A. So write the initial and final momentum for the system. So initial and final momentum, where you're going to select your initial and final is depend on the question. So this is where that you have your before collision. This is before collision, initial. This is the, I'm not talking about this part yet, and this part is after the collision. After the collision, they are moving together. That means initial will be on the left one, and when they are moving together, that will be the final. So now since we are working with momentum, we're going to label your coordinate system X and Y. Now we're going to write initial and final momentum. To the right, P initial is equal, bullet has M times V, but uppercase M does not have the velocity. There is no momentum from that. And then we're going to do same direction. P final will be M and M both are moving with V prime, right? So that's it for the A. Now we're going to move into the B. So part B, use the momentum conservation to find the V prime in terms of other parameters. So we're going to write P initial equal P final, and then you will get the relation between V and V prime. So V prime equal MV divided by M plus M. Okay. So now we're done with the B, and now C. Use the energy conservation by choosing the initial as bottom of the pendulum and final as top of the pendulum, then find V prime in terms of other parameters. Okay, so now we're going to select energy conservation, that we don't want the direction, but we need to select initial and final for the moment. So I'm going to write this as my initial position, this as my final position. I'm going to choose this as potential energy C, right? So now I'm going to write initial information. Potential energy initial is 0. Kinetic energy initial is M plus M V prime squared and divide by 2, half M V squared. Okay. So now we prime, we can write little lower, not to confuse, it's not power 12, it's V prime power 2. Write V prime in here, okay, power 2. And then we're going to write it for the final place. And the final place, potential energy final will be, according to potential energy 0, we have M plus M, both masses together, and G and H. At the top point, kinetic energy final going to be 0. At this place, that's the maximum height it will reach. Okay. So now we're going to write that in the bottom. We will write E initial. Let me change the color because that's not the good color. E initial is equal potential energy initial plus kinetic energy initial. As you can see, that will be m plus m over 2 and v prime squared. And E final, we have both of them, kinetic energy and the potential energy. Potential energy is m plus mg and h, and kinetic energy was 0 because that's the maximum height. So now by using energy conservation, we will be able to write E initial equal E final, right? So that means m plus m v prime square divided by 2 is equal m plus m g and h, right? So now what the question is asking, find v prime in terms of other parameters, right? So now you can see v prime equal, this part will cancel out, right? v prime is equal to v prime is equal to 2g h and root of that. Okay, so now that's the part that we have done for the C. Okay, so now part E. No, part D. Part D, now find H in terms of V and the masses. Now we have V prime in two different ways in part B and C. We're going to make them to equal each other because both are V prime. Square root is equal mv over m plus m, right? And then you can find the H from this. Square both sides first and then divide by 2g. Okay, square both sides will give you m squared v squared and m plus m squared, and you're going to divide by 2 and g. 2g. If you need more steps, you can write it. So that will be the H. Okay, so now E is the time that we're going to plug the values. You see, you do not plug any values unless I ask you to do so, because some of the constant will be cancelled out, and I can see process very easily without seeing the numbers, right? Because when you write each number on those sentences, it's very hard to identify what you are doing. And also, this is the learning method, the skills that you need to learn, solve the problem by using the parameters, and then see, plug in the numbers into the equation, then you can calculate it for different numbers. So that's the way that we can easily see what will happen with the different parameters. Okay, so now we're going to calculate the H. Calculate H if m equal this, and v equal this. Okay, so let's calculate H. H equal lowercase m is 0.2 and power 2, and velocity is 10 and power 2, and going to divide by 2 times 9.8, and m plus m 0.2 plus 0.5 is 0.7 and power 2. Okay, calculate it, and then you will get the H answer. I have around 0.4. That means, according to those numbers, your pendulum will reach the height here, very small height, it is 0.4 meters or 40 centimeters. Okay, so now depend on the velocity, depend on the masses, this number is changing. Okay, so we're going to move into the question number 3. My basic idea about the question number 3 is working with the impulse little bit, but it is a two-dimensional problem that I want to do it here, but even one-dimensional problem, then process will be simpler than this, that you should know how to do it after you do the two-dimensional problem for this example. Okay, so now let's read it. This is overhead view of the path of race car and wall collision is shown below. Just before the collision, car travel at speed. So this is the where the car travel. The initial. So V initial is given as 70 meters per second. Let's write it in here. V initial equal 70 meters per second. And the line 30 degrees as shown. And just after the collision, it travel at a speed 50 along the straight line, as you see it in here. V final will be 50 meters per second and 10 degrees. If total mass is 1 and mass of the car is 80 kilograms, what will be the impulse on the car due to the collision? So now it will hit the wall. We know that wall is just staying there. Wall will not move, right? So car will hit and then change the direction and move, right? So now it's asking you to calculate the impulse on the car, right? So now first thing is you need to draw it your x and y axis. Since you have y axis already in there, I'm going to draw in the same place. X also you have it in here, but let's make it on line x and y directions, right? So impulse is change of momentum. Change of momentum in x direction and change of momentum in y direction is needed in this problem, right? So let's write x direction, change of momentum. What is the change of momentum in x direction means? That means momentum final in x direction minus momentum initial in x direction, right? So now final momentum in x direction, this is we are using vectors. You see that this is the vector that I need. And this is the V final. We know the mass time V final times cosine of 30, cosine of 10 will be your final. Okay. So final will be M V final as I label, that is this vector, momentum vector, times the JSON will be cosine of 10 in there, right? And then minus initial momentum in x direction, you see that I need this vector, right? So moving in this direction, that's also in x direction, that will be mass V initial times cosine of 30. Okay. So since your informations are given, you can definitely plug in here, right? So mass is given 80 and V final is 50 and cosine of 10 minus 80, 70 times cosine of 30. And what I get after I do the calculation in x direction, I got negative 910 units of Newton second. Okay, that is my x directional. That's not the answer yet. That is x directional change of moment. Now you need to do the y directional change of momentum too, right? So I write it for the object only here. I need to emphasize that since wall is not moving, right? I'm writing it only for the object in here, change of momentum. Change of momentum of the car, not the system. Okay? If I write it for the system here also will be 0 because wall does not have any motion. Writing it for the object only because I need to calculate the impulse for the object that is only depend on one object, not on the two, right? So now I'm going to write it for the y direction. Change of momentum in y direction is equal final momentum in y direction minus initial momentum in y direction. Exactly same thing, but it's important that your final in x direction is negative number, but you have mv final sine of 10. That is negative because I am working with this vector now. It's in fourth quadrant. Okay. And then negative p initial y direction is, you see that it is in here. So that will be, the direction is in positive y direction. So that in here, this one, this is the vector that will be similar to sitting on the first quadrant, right? That will be the direction of x. So that will be mv initial sine of 30. Okay. Again, plug the values, and I have dy equal -3495 Newton second. Okay, so now I have the x direction and y direction. Now I need to calculate the impulse. Impulse, we use usually, some people use I, some people use J. Impulse will be, you need to use the Pythagorean theorem, px squared plus py squared and square root. Okay. Why? Because now since I need the direction, I'm going to draw the vector diagram in here. You see from the px and py, both are negative, right? That means your x direction negative will be something like this. This is delta px, right? And y direction one is much bigger than that. It will be in negative y direction, delta py. So now we're going to complete this parallelogram and going to find this. That will be basically your impulse. Okay, let's calculate it first. We have 910 squared plus 3495 squared and square root, and I have impulse equal around 3600 Newton second is the impulse. I'm going to use the symbol J for that. Okay, so now this is not in x direction. Impulse, I need to find the direction. This is just the magnitude. Now direction is, we need to write it in positive x direction. That means I need to give the angle this whole part, right? That is the final angle. But before that, I'm going to calculate this theta first. So now tangent of theta will be equal to delta py over delta px. So calculate it. You have the values, and 3495 divided by 910, and that will give you the theta. Theta is around 75.4 degrees. Okay, but what I need is this whole angle, right? Because we need to give it for positive x-axis. This is the angle that I need to give. That means I need to add, direction is theta plus 180 degrees with respect to positive x-axis. So that will be, if you add 180 to this one, will be equal to 255.4 around. That will be the direction of the impulse. Okay. So now this will be a little complex, that you need to do it for x and y direction. By doing this problem, at least I want you to see that you will be able to do easily if it is in one directional motion, right? You even don't want to use the Pythagorean theorem, you just use it for the one direction. Okay, that's about the impulse. Okay, so impulse will be the same for the wall and also for the object. Okay, so I have my last question about the center of mass in here, right? So these questions also you will be seeing different places, but important thing is you understand the steps that I'm asking to see your understanding. Okay, so now you have T-shaped object. So you made from object A and object B. So object A is this part, right? Let's call it as the A object, and this part the B object, and you have point B center here and center here for these two objects separately. So now let's say this is your first object. I'm going to say mass of A, mass of B, right? And also origin of the problem is given XY coordinate. This is where the origin is, that is the 0, 0 point on the axis. You're going to find the center of mass with respect to this point. Okay, so now let's see what is given. Figures of the symmetric T-shaped portion of upper body that have the uniform thickness having the areal. So this information is important. Uniform thickness having the areal density. This one, areal density is basically mass over area is the areal density, not the usual density. Density is mass over volume. Here it says area density. Area density is mass over area. So you will see why it is given, because the question mass is not given. By giving the areal density and the area, we will be able to calculate the mass of these two objects. That's why. Okay. And so now by neglecting the thickness of the body, find the center of mass of entire T with respect to the 0, 0 point on the figure. Okay. So now first one is finding mass of A and B, right? So now areal density, you know that areal density, you want to write it in here. Areal density means, areal density means mass of that object divided by area. Now in the units, you can understand kilograms over meter squared, right? So now by using this one, I know that I will be able to find the mass, right? Mass will be areal density, that is 5.0, both objects made up from same material, 5.0 times the area. Okay, so now let's write it for the A object. A object mass will be 5, and area of that black shaded part will be, you see that 3 is the length and 1 is the width, then your area will be 3 times 1. Yes, that is 6, and that will be equal to, oh, that is 3 times 15, that will be equal to 15 kilograms, right? And do it for the B object also. Area density is still same. Now for the B object, my red area is 2 times 1. That will be 10 kilograms. Okay, that's the question that asked in part A, because we need the masses first. And now we're going to move into the part B. We need to find X center of mass, right? We have two objects. For two objects, X center of mass, will be able to write your first object. I'm going to label it as MA, and distance to that object, XA, plus MB, XB, divided by MA plus MB, right? So now, do I know XA and XB? What those XA and XB mean? So that's you need to find from your drawing. See that here, I'm going to erase it. And then we need the distance XA. XA is distance from origin to your XA point, this distance. See that this distance is the XA distance, right? So XB distance will be also the same distance we need, because these two are sitting on the same vertical line. So that means XA and XB are the same, but how much is that? That will be, you see that here, this distance is 1 meter and B is sitting in the middle. That means XA and XB both will be equal to 0.5 meters. Okay. So now we can plug it in here and calculate this value first. So MA is 15.0 times 0.5 plus MB is 10 times 0.5. Both are positive in X direction, and going to divide by 15 plus 10. what I get as extent of mass is equal to 2.3 meters. Okay. That is part B. Now part C. Now part C asking y cent of mass. Y cent of mass is equal mass of A ya plus mass of B yb plus and divide by ma plus m. Right? Now we need to see what is ya and yb is. Okay. So now to see that here, so now ya means distance from origin to your A in vertical direction. This distance is ya, right? To yb is the distance. They are not the same. Yb distance is vertical distance to your point B. This is yb, and red one that I label is ya, right? So now what is ya and yb? Let's write it in here. Ya is equal vertical height, that will be 0.5 from the origin, and yb equal how much? That it is in negative direction, and it should be, this is 2 meters. 2 divided by 2, that is 1 meter. So now after that, you can take a look in here if you want one more time. So I make it smaller. A second. Okay. So you see your yb and ya, how I get those numbers. Okay, double check that. Okay, so now we have all the informations to calculate it, but it's very important that you have negative in here. Forget to write that, because yb is in negative y direction. Okay, yb is a negative value. So now we're going to calculate it. 15.0 times 0.5 minus, because yb is minus, and 10 times 1 and divide by 15 plus 10. That will give you y cent of mass I get negative 0.1. Okay, so we almost done. The D is we need to find part D. Okay, I'm sorry. So part D is asking us to find R cent of mass. That means I need to use the Pythagorean theorem. So R equal X cent of mass squared plus Y cent of mass squared and square root of that. Okay. So then you have the values. You're going to plug it into the calculator and find the R cent of mass. That will be 0.1. That will be 2.30 meters. Okay. If you give in this way, definitely you need to give the direction. Because of that, best way to write this one is R cent of mass. Write it in coordinates. You see that your x coordinate is 2.3 and y coordinate is negative 0.1. So I think this is the best way to give the answer. Second way. Okay, that will be your final position of the cent of mass. Now in this this calculation, you see, since I have 2.3 and 0.1, so 0.1 is a very small number. That will give you almost my cent of mass is in x direction, right? But it's very close to 2.3. Okay, so that's it for this worksheet, and let's stop here.